session about the continuous delivery regarding Android development. So, my name is Nemanja Nedic. I'm working as a software developer at Levi9 IT Services here in Novi Sad. I've been doing mobile development last almost 2 years, and last couple of months I'm pretty busy about setting up the continuous delivery process for all of our mobile projects, mostly Android. So today we are going to speak about what is continuous delivery and how does that apply to Android projects. Also, we are going to talk how to set up this. So we are using a Gradle build system, and by that we are also leveraging all the power of that build system to do the whole process of continuous delivery. Also, in order to have that automated as much as possible, we are using a continuous integration server. We are using Jenkins. So, and at the end, we are going to talk about beta distribution, which is the basic last part of the continuous delivery process for Android applications. And I will try to show some demo and how it is set up on a sample application. So, let's talk about continuous delivery. I guess that, well, how many of you did hear about continuous delivery? Okay, this is nice. So this will be brief. We are going to go over the principles of the continuous delivery and also how to build this one. So first up, every commit or every push in, if you're using it, can and should result at least at the release candidate. It might not get really released, but it should get automatically get up to that state. This is very important to change the mindset of the team, to actually emphasize that and to know that whatever they're pushing, that it might be a possible release at the end. So in order to have that and not to waste too many times on actually doing the manual releasing and building, etc. So you need to automate as much as possible. And we are going to show how we could basically automate from pushing a commit to actually ending up on the device. So also a big thing about this that will help you is to put everything into source control management system. So all the configuration regarding the continuous delivery process should be in the source control, so you have the history of configuration, and also if you put it there, it will be on the one place. So if you need, for example, to switch from Jenkins to TeamCity or something like that, it won't be a problem because all the configuration should be on the source code management. And also, big thing and very helpful is that you should always build only once. Basically, whenever some commit enters the process of continuous delivery, it should be built just once, and the artifact that you get, APKs or if your building library is AR files, you should store it somewhere and use it later if you want to deploy distribute through for example, through the Crashlytics, or to distribute it or publish to the Play Store. And finally, well, not finally, still one more, but you want to get the feedback as soon as possible. This means that you want that if your unit test fails, you don't want to wait until all other stuff are done to get the feedback that unit tests are failing. So you don't want your APK be published to beta testers if you know that you have some problems already. So we'll show you later how this can be done using Jenkins. And last one, done means released. So definition of done is changed. You are not now done by, okay, it works on my machine, it compiles, whatever. So done means when the change you put, the story you implemented feature is released at least to beta testers or to clients so they can verify that. And how do we do this? We are going to implement it using build pipelines. And what build pipeline is, it is as a definition, automated manifestation of delivery process, which means that you are going to implement the delivery, continuous delivery through build pipeline, and we will show this at the end, how does that pipeline looks in Jenkins. And what you want to do is not just, as I said before, not just put commit and do everything regarding what the outcome. So you want to build into that pipeline the checks, the valves, so to say, that will check if the code quality is good, if all the tests are passing, if the coverage of the tests are good. So you can do that by using Jenkins. There are some plugins that can help you with that. And how we describe the build pipelines? Well, they consist of stages and steps. So here are the most common, I guess, high-level view of the build pipeline. This is the stages. First one, commit stage, is the stage where you actually, which is invoked after you put something on a source code management system, meaning that you will have, it will be picked up usually by Jenkins and started the process. And this includes compiling, unit testing, checking code quality, and building artifacts. Also can be uploading to Nexus repository if you're using that. So the next step is automated acceptance testing. This means that when you do all the build stuff on the commit stage, you want to put it somewhere for the users to test. But before that, you want, usually if you have a automated test or acceptance test, like for example Calabash or something like that, JBK, whatever you want to use as acceptance testing, you can put that before. And basically next step is manual test stage, where you distribute your beta testers so they can check whatever they need to check before signing off the release or that build. And of course the release stage, where you put basically publishing your application. This one is, so this is the unified view of the continuous delivery process. For mobile applications it's a bit different. I will show you a simplified version. For the most of the Android project, that is quite okay. So these are the build steps for Android project. And what we have here is that we start with building the app, then running tests. This will explain in detail every part of this. Then after that, we're checking the code quality, followed by uploading artifacts to Nexus repository for the later use. If we need to go back and check some old build, we can find it on the Nexus repository and download the APK and install it to check if we want something check what was done before. Also, if you are building libraries, you can put that and use it as a dependency. And in the end, we distribute the APKs through the Crashlytics to beta testers. And I will tell you something about this thing, is that we are missing, maybe you will notice, we are missing a key part, which is release stage. And the problem is that currently there is no easy way to publish apps automatically to Play Store. Google made a REST API earlier this year, I think May, something like that. But it's quite complicated. It has some specific workflows, so it's really not easy to just script it, make a post, HTTP post to some REST endpoint, and everything goes. So there is still no, haven't found any Gradle plugin for doing this, or some plugin for Jenkins or whatever. So I guess if someone has some time, could do that. So that's one thing. And also, as I mentioned before, automated acceptance test. If you are, this depends greatly on the tool you are using. But if you want your automated test to be placed somewhere here, it will be probably after uploading artifacts and before distributing to beta testers. This will ensure that we have a build backed up, and also that we won't distribute something that is not accepted by the criterion. And now let's get into the implementation part. So we are going to use what could be said as the Gradle building blocks. Basically, for every step that we described before, we are going to use some plugins, and we are going to execute some Gradle task in order to build, to implement this step in the process. Firstly is the build step, which consists mainly of the compile and assemble. Assemble because we need it for the testing. That's a problem with the Android, but usually you would just compile and do unit tests. So if you're doing, if you're using Rob Electric and you're doing your unit tests on JVM, then you can probably, and you should do this in this phase. This means that you will find your problems, for example, compile problems or unit test problems, early as possible. So on the start of the process, if something goes wrong, this will fail. Also, this is the initial step. So whenever you put something in the source code management system, this will be automatically triggered. Next step is running tests. So I didn't set integration test, unit test, UI test, whatever. So whatever you put basically in the Android test directory, you should be running this here. It requires that you have a device connected or emulator started, so it can be slow. Especially there are some plugins for Jenkins where you can basically automatically create emulator, start it, and then destroy it after this, but it tends to take lots of time. So if you have a physical machine where you're building this, you just buy some phone and plug it into. So for doing this, this one additional point that you want to have is that you want to create a coverage report. You want to collect the test coverage for the later inspection. So next step, and as you see below, so on every side you will see what are the tasks that you want to create. So basically there is a connected check which is doing the tests and create debug coverage report for, well, exactly that. Next step is code quality, and this means that you really want to measure how good you are doing with the coding exactly, so you can implement everything in different ways. So you want to minimize the number of VTFs on the code review. So you should use Android Lint. It's really helpful tool if you're doing programming in the Android Studio. It's built in and it really tells you immediately if you're doing something wrong. Also, you could generate lint report by running the lint. Also, you can configure that if there are some major errors, lint can break the build, which is useful. Also, if you want to track the code quality over the time, there is one tool that is most popular, which is the SonarQube. This is a server where you publish all the reports which are done using the tools for inspecting the code. And you can run the Sonar runner, which will do the inspection for you. It will use, I think by default, find bugs to do the code inspection. Also, it can collect the test coverage report, also can collect the Android lint report. So this will do the inspection on the build machine and upload the result to the SonarQube server, where you will see how that looks, and you will have a historical view of how well you are doing on the project. Especially managers are like the numbers there. Next up is to, when we did the build and check everything, we want to back up our builds and want to upload to Nexus server. Nexus repository is one of the most famous and most used artifact repository. It's also used by Maven, which is the default one. And so you want to have your local Nexus repository for your projects where you can upload your artifacts. I did the demo at the end. Will show that. So I set up, in one day, set up the Nexus repository, Jenkins, set everything on my laptop. I don't recommend that, but it's possible. And at the end, we want to upload the APK to Crashlytics. Why Crashlytics? Well, it's easy to use and does the job. We did use TestFlight before, but the problem with TestFlight is that Apple bought it and discontinued the Android support. So if you want to use TestFlight, you can use it only for the iOS projects. With Crashlytics, you can use you can distribute builds also for the iOS and for Android. And as I said, it's very easy to set up. You should use the ID plugin to set up the Crashlytics. It will also do bug reporting, crash reporting, and also some simple analytics, which is the recent feature of Crashlytics. So we are going to concentrate on actually showing the beta distribution through Crashlytics, which is also one of the recent features. You just need to use the Crashlytics plugin for Gradle and call the task, which is this Crashlytics upload distribution release. And this will do the upload, and magically it will be appeared on the Crashlytics site. We'll show that also later. Now let's go to how to set up that on Jenkins. So we have all the components. We could basically build and execute all of those build tasks from command line on our development machine, but we want to automate that through Jenkins. So how we are going to implement that? As you can see, we want to use one build job per build step, meaning that for all that we said before, we are going to use a separate build job, and we'll show later how to connect them. So we have a basic for everything: build, test, code, quality, upload artifacts, and beta distribution build jobs. So this is how does it look on the Jenkins dashboard. So the main thing that will execute the Gradle task is the Gradle plugin for Jenkins. And as you can see, it's not that complicated to set up. What you want to use is to use a wrapper. This is the default thing that comes with when you create a project in Android Studio. And this also helps to have reproducible builds later on. And of course, in the tasks, you define the task that you want to run in this build step. Next up is the build name setter plugin. This will help us to have the consistent build names across all the build steps and build jobs. The problem with the Jenkins is that every job has his own counter for the build name, actually build number, and by default that the build name is build number. So we can use something like this expression to actually set up the custom build name. So in order to connect the dots, to connect to the jobs, you need to use parameterized trigger plugin. This plugin enables us to trigger subsequent jobs, and we can also send some parameters to that job. So in the first part you define which project to build. Basically this is the next build step, and also you want to trigger only when your build is stable, so you don't want to trigger next build step if the previous one failed. And also you can send parameters. What we are doing here, which is quite important, is that we want to set the build number so that subsequent jobs knows which are the initial build number. And we can use that also, as you saw before, that we can use that to set the build name. And we'll have the same build number in the build name for all the build jobs. So next one is, again, as I said, you want to build only once and to check the code only once from the Git or SVN or whatever you're using. So in order for build jobs to share what has been done before, you want to use clone workspace plugin. And here you define on the first build step, you define what thing you want to archive for cloning, and you want to use everything. So this wildcard is actually using exactly that. And also you don't want yeah, as I said this, so you want to archive all the files, and you don't want to archive anything if the build fails, because you won't trigger anything after that. Next thing is how to set up on the subsequent build job. You set up source code management as the clone workspace. You're not actually going to check out the code again. Why were you doing this? Because it might happen that when you started the build, first few steps are done, okay, but then between the second and third, for example, someone also pushed some code, and then if you're going to check out, clone the code again, and you will end up with a different code base. So by selecting parent project, you will reuse the workspace and all the files that were in the first place checked out from the Git, for example. And how this looks in the build pipeline view. Basically, you can see that I was changing the JVM on the machine, so there are like some failures on the first step. But when the build pipeline starts, basically you have a first job starting, then if it's green, going to the next, etc. And if you end up to the end of the build pipeline, it will be all green, and you will have your APK pushed to Crashlytics for beta distribution. And let's see how that looks. Basically, it's quite simple. It's all automated, and you just want to, you're defining, setting up the project using the ID plugin. You can do it manually also. There are like a few changes, adding Crashlytics plugin to Gradle, also putting some constants and parameters in the manifest file, and that's all. And what you see is that when you log into the dashboard of the Crashlytics, you will see something like this. And the top is the most recent build. You can set the release notes. It's not really visible here, but yeah, we'll be posting these slides on the speaker deck or somewhere. So you can select release notes. You can see down there. You can add people to that build for testing. And when you send someone an invitation for the build, what they will see is the next thing. You will need to install the client application, which is called Beta by Crashlytics. It will be done not automatically, but the Crashlytics will guide you through the process. Once you set up your beta app, you will then receive notification from that app whenever a new release of the apps that you are testing have been released. So you will receive email so that someone invited you to download the beta application. Then next thing is to actually installing that beta by Crashlytics app, and you will see that what is the latest release that you have of the app and what you want to install, and it will install the app and you can run it. This is really just a template application that you get when you create a new project. And demo time. So try to be quick. Let's try this. Okay. So whatever. You can see the project structure. It's very simple. What I want to emphasize here is that we have a Gradle folder with wrapper settings, and also we have some Gradle files put here for configuring some parts of the system. What I will now guide you through is how this looks. Basically, for the main project, you want to import those files, also set up the repositories, and that's all. Basically, nothing much. And in the app, we have a few things. So we are putting now a version code and version name from our. We want to put there the build number from Jenkins. Why we want to do that? Well, from the first principle that I shown, every single commit can be a release candidate, at least. So you cannot have like 1.0 snapshot, and you do every build and it's always the snapshot. So every time you start the build, you want to end up with a version that is different. So this way we can have a version code which will be actually the build number on Jenkins, and a version name which we set like major, minor. Then we include the build number from Jenkins in the version, and you can do that by just adding simple Java GUI class for version, basically major, minor, and build, and at the top you are importing the source build number which we did from Jenkins, which is the environment variable, and we put it there also for this thing here. Let me see if this will. So if we don't have the continuous integration build number, we use like some number we want to use. For example, this is 3 or 4. This is just for your development purposes. So if you are doing during the development on your machine, you don't have the source build number, and you want to do that to ensure that you will build the app, because version code must not be now. And the next thing is to also here couple of things. You want to enable test coverage for the debug. This will record all the test coverage. You can see the report later on. You could use Sonar runner to upload this to the SonarQube server. And again, for Sonar, it's basically just putting the Sonar properties. I think the talk after this one will go deep through the using of Sonar and doing the code quality checks. Also, you want to use the Android lint profile, which is a quality profile for Sonar, which will add some checks from the Android lint, so you have the same thing in your IDE, Android Studio, and also it will be checked during the build. And that's also some stuff to do. So this is all you can get from the when you go to documentation for Sonar. You can get all the properties you need. So when we want to upload the artifacts, we use Maven plugin, and quite simple. We define the Maven repository credentials. This is just a test installation. We want to use unique version. We don't want to use snapshots because the Maven way of versioning is to use actually snapshots during the development. Then when you release something, then it's an increment of the version. Also you will need to define the group. This is for the Nexus repository, so they know where to put your stuff. And so let's try to now see how does it look in Jenkins. So this is what you saw earlier, and first one, if you configure it, come on. So this is the simple stuff. Here you are going to check out the code from Git. So I'm using the local Git repository, not remote one. Also define the branch you are going to use. We could talk a bit later about the branching model, but this is a separate talk. And also polling this source code management. So here is, for example, for that versioning file, we want to use the source build number, environment variable, but we need to set it up to be the same as build number this one we get from Jenkins. And at the end, we set the name of the build, running the task, which is the clean assemble. We want to do the clean because we want to remove all the stuff from previous build. We don't want that to interfere. So, and also archive the workspace for source code management, and at the end trigger the next build. So you already saw that, and this is how it looks as a build pipeline. So it's the thing that you saw it before. You can also run here. You can check the console output for this step. So let's try to do some demo to see if this will work. So let's change something. So I won't be pushing, I'll just commit because it's on my local repository. And let's see if this should, let me see if it's queuing. So yeah, so basically this will start the first build and building, and also you can see that process in the build pipeline. So first one completed successfully. See for the next one. This is not the nicest UI, but it's effective. You can see the status of your build pipeline. This will start instrumentation test, probably, if this works, hopefully. So just wait a second. I have only one test, so just to check the code coverage report, etc. So also next up is code quality. One thing that you want to be aware is that if you are integrating with SonarQube, there are some problems. For example, Gradle Sonar Runner plugin doesn't work with the latest SonarQube server, and the one that it works is actually using Gradle 2.2, which is not yet released. And if you set that as a beta build, then you will get the problem because Android plugin doesn't support Gradle 2.2. So it's easier to use the previous version. And we have uploaded to Nexus, and we'll show you after it how does it look. And this should also, yeah, started. So let's just start the demo device. I wanted to show it on my phone, but I couldn't manage to get the screen from the phone to the projector. So let's try with this. So in the meantime, you will see that we should have a new version here. Or not? Yeah, 39. So also in the SonarQube you should refresh it. So it's really big file, only 46 lines of code. Yeah, you have also the same thing, 39. You can drill down the issues if you have one. And also here is the Crashlytics. Let's refresh this. Also should display the latest build or not. Yeah, here is the latest one. So I can put the release notes. And I can add tester. I will add myself here and see if this started. Yes. So I should get a notification. So not this one. Start the app and refresh. If the internet is working, we should have info that there is a new version of this app. We'll see. So from this app you can see all the apps that you're testing, and you can install the version whatever you want. I guess it's not going according to plan. So basically this is it from the demo, and if this goes well, we should see the something, but I guess it's not working very well. So let's get back to slides. I don't think that will do something. Let's maybe try again. Oh, here. No, timeout. So I guess the internet is problem. Anyway, let's switch to this. So questions. Sorry for taking a bit too long. Yeah.
Okay, so this is when things go fine, but if one of the human or automated gatekeepers stops the thing, what do you do with the repository? Do you backtrack the thing? Do you reject the commit push?
So if something fails, you can set the email notification to Jenkins. So whenever some of the build stuff fails, you can send notification to whoever you want. Usually it's all the team. So also all the team should monitor this build pipeline stuff, so they can see the status of the build. And if something fails, it should notify, or it will be shown, and subsequent steps won't be executed, and you will basically discard that commit. You will want to fix that and create a new one.
Okay.
Yeah.
How do I limit when I commit, and I don't want it to run Jenkins and create new APK, new release? How do I limit that?
That's a good question. So the question is how to limit if you don't want on every commit to do the build. So if you're using Git, you could have a branching model. So when you are doing some feature, you are doing that on the feature branch, and building and committing there, and then you merge it to master, which is your main integration branch, or however you wanted to call it. So when you merge to master, it will be one merge commit, which will be then trigger the build. Yep.
I suppose human testing and code review is done on that other branch before it is actually merged into master and before the build occurs.
So you want to basically, yes, you do some testing before. This depends on the organization of the work, but on some project that I work on, we are actually doing that. We are making these builds whenever we finish some feature, some user story, and also the code review is done by using pull requests. So when you finish the stuff, you create a pull request from your feature branch to your integration branch, and then someone will check that code, and it won't be merged before it's approved.
Yeah, and you won't have a beta APK before it's merged.
Exactly. Any more questions? Okay, thanks a lot.